So in the previous lecture, we were discussing about what is the difference between a gas and vapor, what is the how the steam will be generated or formation of steam. So when you are discussing your formation of steam, we are discussed that when the saturated liquid, which is the liquid at 100 degrees centigrade, when the water is ready to boil at that temperature, so when you are giving the heat, it will be converted to wet steam. What's wet steam? That liquid and vapor both are in the same exist in the same phase. So that steam is your what? That steam is your wet steam. So what is wet steam? Some of the important. So today we will discuss some of the important term of steam. So that is your first wet steam. What is wet steam? Mixture of dry steam and the water particle as moisture. So that is known as your what? Wet steam. Then when you are giving the heat to the wet steam, it becomes dry saturated steam. So what is dry saturated steam? Which is free from moisture. Or you can say the vapor at 100 degrees centigrade is known as just saturated vapor. Then what is superheated? Then superheated steam. What is superheated steam? So when you are giving heat to the dry saturated steam, it becomes superheated and its temperature will be increases above 100 degrees centigrade. That means steam exists at the higher temperature than its saturation temperature. It's known as superheated steam. So superheated steam will be act as a what? It will be act as a gas. So we can say the superheated steam can obey all the gas law. Okay, if the question will come, so which steam is invisible to naked eyes? That you can say that superheated steam is invisible to naked eye because it will be act as a gas. Okay. Next, what is dryness fraction? So dryness fraction basically known as the quality of steam. What is quality of steam? It defines as it only applicable to what? It applicable only for wet steam. So we want to know what is the quality of wet steam. That means the amount of water vapor present in the wet stream, that is known as a what? That is known as a dryness fraction. So how I define it is defined as the ratio of mass of dry steam to the mass of total steam. So what is your total steam? In the total wet stream, that mass of vapor and some of the moisture will be there, mass of vapor and some of the moisture will be there. So total wet steam mass will be mg plus mv. So vapor will be denoted as g and liquid will be denoted as f. So mass of vapor, mass of dry steam means that is mg or that is vapor divided by total mass, total wet steam. Total wet steam means that mass of dry steam plus mass of liquid. So dryness fraction will be denoted as x. X is equal to mg by mg plus ml. What is ml? Mass of water vapor. Mg is your mass of dry steam. So if you say your saturated liquid or saturated water, so in the saturated means water at 100 degrees centigrade, there is no vapor. So your mass of vapor will be what? Mg is equal to 0. The 0 by something is 0. So for saturated liquid, the dryness fraction is 0. So if you say the dry saturated steam, in the dry saturated steam, there is no vapor free from moisture, no mass of water vapor is there. So it is free from moisturization means only mass of vapor will be there. So mass of vapor mg will be there. Mg plus what is mf? Mf is 0 because it is free from moisture. So mg by mg is equal to what? That is 1. So x is equal to 1 for dry saturated steam. X equal to 0 for saturated water. So if the question will come, find out the quality of steam. So quality of steam means you have to find out the dryness fraction in percentage. So dryness fraction will be come in percentage. So if you multiply 100 degrees, that will be going to give the quality of steam. Quality of means what is the amount of water vapor present in the wet steam, that is your quality of steam. Okay. Then we go for wetness fraction. Wetness fraction, how I define? It will be defined as what are the amount of water vapor present in the total wet stream. That is mf by mg plus mf. The wetness fraction will be 1 minus x. What is your x? Dryness fraction. 1 minus dryness fraction will give us wetness fraction. So you know that when 0 degree centigrade ice will be given the heat to the 0 degree centigrade ice, then it will be converted to 100 degrees 0 degree centigrade water. Then if you are giving the heat to the 0 degree centigrade water, it will be converted to 100 degree centigrade water. That means it will be a saturated liquid. So then from that, how much amount of heat will be required to convert 0 degree centigrade water to 100 degree centigrade water? That means saturated water. So what are the amount of heat absorbed? That will be denoted as what? That will be denoted as enthalpy. So to calculate what are the amount of heat absorbed, that will be denoted as enthalpy. So we can say enthalpy of saturated water or that will be said as sensible heat. It will be noted as HF. What is HF? It is defined as the amount of heat absorbed by 1 kg of water during heating from 0 degrees centigrade to saturation temperature. What is your saturation temperature? 100 degrees centigrade. So 0 degrees centigrade of water will be converted to 100 degrees centigrade of water. Only temperature will be increased, so it will be known as a sensible heat, or you can say that it is your enthalpy of saturated water. It will be designated as HF. So from where you calculate HF? HF will be calculated from the steam table. Okay. After this term, we will discuss what is how we can use steam table, how you can use Mollier diagram. Then next is your enthalpy or latent heat of steam, that is HF. So after the saturation temperature means at water at 100 degrees centigrade. If you are giving the heat, the 100 degrees centigrade water will be converted to 100 degrees centigrade vapor. Yeah, the 100 degree means what? Temperature is constant, but the water will be converted to vapor, so phase will be changes. So though phase will be changes and the temperature will be constant, so that is known as what? Latent heat. Latent heat of steam, or you can say that is a latent heat of vaporization, HFG. Okay. So how you can define it? It is defined as the amount of heat energy required to convert 1 kg of saturated water into dry and saturated steam, keeping the temperature and pressure constant, is known as what? Latent heat of steam, or you can say latent heat of evaporation or vaporization. So it is denoted as HFG. So where you can get this value? You can get this value from the steam level. Next is your enthalpy of steam or total heat. What is enthalpy of steam or total heat? So it may be defined as the amount of heat required to convert 1 kg of water at 0 degree centigrade to what? 0 degree centigrade to your 100 degree centigrade vapor. The amount of heat required to convert 0 degree centigrade water to dry saturated steam or 100 degree centigrade vapor is known as what? Is known as enthalpy of steam or total heat. So how much amount of heat will be? 0 degree centigrade, you have to convert it to 100 degree centigrade water, that is HF. Then 100 degrees and then 100 degree centigrade water will be converted to 100 degree centigrade vapor, that is HFG. So HF plus HFG, that means sensible heat plus latent heat, HF plus HFG, that will be give us H. So where you get this Hg will be also calculated from the steam table. Then what will happen? That is a dry saturated steam, that means vapor at 100 degrees centigrade. If you again add the heat, what will happen? Its temperature will be increases to what? Increases to above 100 degrees centigrade, and the steam become superheated steam. So it is the amount of heat required to convert 1 kg of water at 0 degree centigrade. Water from 0 degree centigrade to superheated steam. Superheated steam means above 100 degree centigrade temperature steam. So that steam at constant pressure is known as what? Enthalpy of superheated steam. So how can we get the formula for enthalpy of superheated steam? See HF. What is HF? 0 degree centigrade water will be converted to saturated liquid. What is HFG? Saturated liquid will converted to dry saturated vapor. Then dry saturated vapor will again converted to what? Superheated steam. Is again converted to superheated steam. So that is known as what? That was discussed as superheat, as I discussed before in the previous lecture. So how you can get the heat? Heat will be Q is equal to NCPDT. Here mass is equal to 1 kg. So that is CPS. What is the temperature difference? T superheated minus T saturated. So that is equal to HF plus HFG plus CPS into T superheated minus T saturated. What is HF plus HFG? That is your total heat content Hg. So Hg plus CPS. What is your CPS? Specific heat at constant pressure of superheated steam into T superheated minus T saturated. So by using these formulas, so we can get the enthalpy. Okay. Then enthalpy of wet steam. So what is enthalpy of wet steam? Enthalpy of wet steam, it is the amount of heat required to convert 0 degree centigrade water to 100 degree centigrade of wet steam is known as what? This is known as your enthalpy of wet steam. Okay. So how you can get the wet steam? So you know that when that will be considered as wet steam, the dryness fraction must be there. So enthalpy of wet steam is equal to HF plus X into HF. All the enthalpy unit are, that is your small h means specific enthalpy, so all the unit are what? Kilojoule per kg. So if you have to calculate the enthalpy H, capital H, then you have to find out what? You have to multiply mass into specific enthalpy, then you can get the capital H, that is your enthalpy. Okay. Next we will discuss your temperature entropy diagram, TH diagram. And before we will discuss TS diagram, first we will discuss when see the you can see here. So when you are going for the when you are discussing your formation of steam, so 0 degree centigrade of ice, see here, 0 degree centigrade of water, sorry, 0 degree centigrade of water will be converted to what? 0 degree centigrade of water will be converted to 300 degree or 200 degree, that will be superheated steam. So this is your what? This is for your this line from C to D, D to E, E to F. That is your only for what? Only for atmospheric pressure. So if you are increasing the pressure, so you can get this type of diagram for another pressure. Suppose this is a pressure is here for 2 bar. So if you are increasing the pressure, you can get the graph like this. You can get the graph like this. See, pressure increasing, pressure of 10 bar, pressure of 20 bar. So this way you can get the diagram of different pressure. Yes or no? This is for atmospheric pressure. Pressure is equal to 2 bar, pressure is equal to 10 bar, pressure is equal to 20 bar. So if you are increasing the pressure, the graph will be like this. So these are the point of what? These are the point of saturated liquid. These are the point of what? These are the point of your saturated liquid. Yes or no? These are the point of what? Saturated vapor or dry saturated vapor. Yes or no? So if you are increasing the pressure and you get all these graphs, so if you join all the saturated liquid line, wait a second. If you join all the saturated liquid line and if you join all the saturated vapor line, this both the line will be meet at a point. Okay, this point is known as your what? Critical point. This point is known as your what? Critical point. And this line from this to this, when you are joining all the saturated liquid line, you got the curve. This curve is known as your saturated liquid curve. And when you are joining all the point of saturated vapor, this curve is known as your what? This curve is known as your saturated vapor line. So right hand to the saturated vapor, this is a saturated vapor line. So right hand to the saturated vapor line, these are the what? Superheated region. So left to the saturated liquid line, this area is known as a subcooled region. And in between this curve, this region is known as your what? Wet region or wet steam region. Yeah. So this is the saturated liquid line and this is the saturated vapor line. So this way we can get the graph. This way we can get the graph like this. This is your what? This is your pressure and volume line.